Hello world, Noah here. In this video we're going to talk about operator overloading in Python. First I want to give sort of a general idea of what operator overloading is and why it's useful. Then we're going to actually implement an example in Python. Python is not the only language to support operator overloading, but it will serve as a great example for us. And finally, I'll show you some examples of operator overloading in the Python standard library that you might not have known were operator overloading before. So the first thing that we want to do, of course, is to sort of understand what operator overloading is. And to understand it, we'll start with one of the most basic things that you can do in a programming language, and that is simple math. I'm talking about addition, subtraction, multiplication, division, so on and so forth. So for example, I can have, two numbers, and I can add them together by using the plus sign. And if I run this, it will do exactly what you expect it to. It will print out 2, just like that. And this makes perfect sense to us, right? We see two numbers, and we see a plus sign in between them, and we know that when you have two numbers and you add them together, you just add their values together and you get a new number. 1 plus 1 equals 2. Super, super obvious. The basic idea with operator overloading is, can we take this super obvious and super basic math construct, you take two things and you add them together, and can we apply them to things other than numbers? And you might have already seen this before. You might have seen us sort of apply it to strings as well. So if I go ahead and I write hello, and then I'm going to add the string world, and we'll put a space in there, then this will do exactly what you expect. It'll print out the message hello world. We're not really adding the strings here, we're concatenating them. That's the coding sort of term for that. We're basically taking the first string and we're attaching the second string onto the end of it. So it's not quite adding. We're not adding up all the letters or anything like that. We're just concatenating the strings. But again, we're using the addition sign, and it makes perfect sense. Adding numbers, concatenating strings, they're two different operations. They're two different things, but they both use the same addition symbol, and they both make perfect sense to us. There's no sort of confusion here or anything like that. And so the basic idea is, can we apply this beyond just numbers and strings? Can we apply it to our own types? Can we, allow us to add, subtract, multiply, divide, modulo, so on and so forth with our own user-defined types, aka classes? And the answer, of course, is yes, and this is the process that we call operator overloading. Now, before we actually do the operator overloading stuff, let's actually just implement a very basic example without it, and then we'll quickly show how to sort of convert ourselves back over to operator overloading, and we'll look at why it's a good thing, why it's useful. So I'm going to delete this example right here, and we're going to create a class called vector. Vector as in sort of the mathematical representation of a vector. So a vector is sort of a fundamental structure in mathematics. You can think of it for our sake as just a list of numbers, and we'll define some operations that you can do with them. So for example, I'm going to, let's say we're to declare two variables. I'm going to make a, which is a vector that contains the numbers 1, 2, and 3, and then I'm going to say that b is a vector that contains the numbers 9, 10, and 11. So we want to define two operations for the sake of this video that vectors can do. We want the ability to add vectors and to multiply. And so basically what we're going to do is we're going to say that if you add a vector to another vector, we're going to add all of their variables, all of their values element-wise. So what that means is that a plus b is equal to a new vector, but we're going to take each element. So we're going to take this 1 right here, and we're going to add the 9, and we're going to get 10. We're going to take the 2 and the 10, and we're going to get 12. We're going to take the 3 and the 11, and we're going to get 14. And so the basic idea is that when you add two vectors, we add up the two elements of each, and we stick it in the new one. So 1 plus 9 is 10, so on and so forth. Pretty straightforward. We also want the ability to multiply a vector by a scalar. So for example, if I do 2 times a, or for now we'll just say a times 2, then this will give me a new vector where each element is multiplied by that value. So a times 2, we're going to take the first value, which is 1, multiply it by 2, we get 2. 2 times 2 is 4, and 3 times 2 is 6. So these are the two operations we want. We want to be able to add two vectors together and get another vector where the components are added component-wise, element-wise, and we want to be able to multiply a vector by a scalar, by a single number, and to have each value be multiplied by that number. That's our end goal. And I'm going to leave that code because we're going to actually use it to test our code. But for now, let's go ahead and actually define a class that we're going to call vector. So we're going to declare vector, and we're going to write our init function. That's going to take our numbers, and we'll store it locally. Okay, so basically we've written sort of our init function, our constructor for the vector class, and it's going to take a list of numbers and it's going to store them. So I can comment that code out now because it is valid. And so let's go ahead and actually implement addition, but we're not going to use operator overloading yet. We're just going to implement a function, or a method rather, that's called add, and it's going to take another vector. So you're going to call the add method on one vector, and you're going to pass it the other vector, and then we're going to do something with it. The first thing that we want to do is we want to make sure that the other value that you pass is actually a vector, because if you try to add a vector and a string, or a vector and a scalar, or a vector and anything else, it really wouldn't make sense to do that. And so we want to make sure that you're only adding two vectors. And so we can just add an if statement. We can say if the other is not a vector, so if not is instance other comma vector, if the other variable is not of type vector, then what we're going to do is return not implemented. And you might think, maybe we could just return none, maybe we could raise an exception or something like that, but we're going to return not implemented, and this is going to make more sense when we get to the operator overloading part, so just trust me on this for now. But essentially, we have this if statement, so if the other value that we pass is not a vector, then we sort of let the caller know that we can't do that, but otherwise we can actually go ahead and add the two vectors together because we know that other is of type vector. The important thing that we want to do here is that we want to make sure to return a new vector. We don't want to modify the current vector that you're calling it on. So you don't want to modify self.nums or other.nums at all. Rather, we want to return a new vector sort of that has the new result, the new value in it. And this will again make more sense once we get to the operator overloading part, but hopefully it makes a little bit of sense now. We don't want to modify either vector, we want to just return a new one. And so what we can do, I'm just going to write the code really quick to do this. Even if this code doesn't make sense, I think it makes sense, but even if it doesn't make sense to you, that's not really the point of this video. So we're just going to do a plus b for a comma b in zip self.nums and other.nums. So essentially what we're doing here is, let's zoom out a little bit. Essentially what we're doing here is we are sort of zipping together these nums and other nums. So for example, it's going to return a tuple that has 1 and 9, then the next one's going to have 2 and 10, and then 3 and 11. So then we unpack the tuple into A and B, where A is whichever value from A we have, and B is whichever value from B we have, and then we just want to add them together. So this is very, very straightforward. That's all we need to do. You could write this with a standard for loop and a list, and you append to the list each time the loop runs. I just wanted to write it like this because it's pretty quick, and the point of this video is not to implement the vector class, it's to actually implement operator overloading. And so we have this method, and this method works great, and so let's test it out. We're going to print out a.add b, just like that. And so let's run this, and it's going to give us this not very useful output. So let's really quickly override the string method, and we're going to return comma space dot join, and then we just need to map self.nums to a string. So we're going to take each number in our vector, we're going to map it to a string, and then we're going to join them all together with a comma. and space. So this will be the output. So 10, 12, 14, this is exactly what we expected. So basically we do a dot add b, it's going to give us back a new vector, and the values are going to be 10, 12, 14, exactly what we thought. And the reason why we want to return a new vector instead of modifying the other one is because if I write this code like this, so I print a dot add b twice in a row, you see that we get the same result, which makes a lot of sense. Because if I did a dot add b and this sort of modified a, and then I did a dot add b again, and now I had a modified version, this would be kind of confusing. And when we get to the operator overloading part, it would be even more confusing. But the basic idea is that it makes a lot more sense to just return a new vector instead of modifying either one. But okay, so we have this sort of setup here where you can call this add method on one vector, you pass it another vector, and it'll add them together. That's great. It's not the nicest looking thing, but it's not terrible. But of course this video is about operator overloading, and so let's actually do that. What we can do is we can sort of define what the addition operator does when you have two vectors. And it's really, really easy to do. In fact, we only need to add 4 characters. Instead of calling this method add, we're going to call it underscore underscore add underscore underscore. And other than that, we don't need to change anything else about our class definition. So instead of calling the method add, we're going to use the special underscore underscore add underscore underscore name. And as you know, these methods that begin and end with 2 underscores are special methods that are reserved by Python, and that means that they do special things. We know that init is used for the sort of constructor, str is used for the string representation, and so add is used for operator overloading, for overloading the addition operator. And so now what we can do is instead of doing a dot add b, we can just write a plus b, just like that. And if I run this, you'll notice that it gives the exact same result of 10, 12, 14, but our code looks a lot nicer. Once again, this makes perfect sense to us. You know, there's no sort of confusion as to what we're doing here. We're just taking 2 vectors and we're adding them together. But this code looks a lot cleaner to just write a plus b instead of doing a dot add parenthesis b and parenthesis. It's, in my opinion, just a lot nicer, a lot cleaner. And so that's pretty cool, but addition is not the only method that we can override. We can also override, subtraction, multiplication, division, modulo, and lots of other things. But let's actually just go ahead and override multiplication so we can do this thing here with the scalar multiplication. And so to do this, we're going to implement a method called underscore underscore mul for multiplication, of course. And what we want to do is we want to allow you to multiply a vector by a scalar, and by scalar we mean an integer, or I guess a floating point number would also be fine. And so what we're going to do is we're going to say if not is instance other int, and not is instance other comma float. So if the other thing that we're multiplying is not an integer and it's not a float, we want to return not implemented. And we'll get back to that in just a second. But otherwise, we want to return a new vector where each value is multiplied by that scalar. So we're going to return a new vector, and it's just going to be a times other for a in self.nums. Just like that. So we're going to take each value in, self.nums, in our number, in our vector, and then we're going to multiply each value by the other, which is the multiplier, and then we're going to wrap this whole thing in a list comprehension, and we're going to return a new vector with that value. And so now we can write something like we had down there. We can write a times 2. We don't have to write a dot multiply 2 or anything like that. We can just write a times 2. And once again, this is perfectly clear as to what we're doing. There's no confusion, but as you can see, it just works, and it does exactly what we'd expect. It gives us a new vector with the values of 2, 4, and 6. Let's just talk about a couple of loose ends here, and then we'll move on to the last part of the video. The first thing that I want to mention is I mentioned before a couple times that we want to return a new vector instead of modifying the current vector. And the real reason with the operator overloading is if I write a plus b 2 times like that, it's going to, of course, give me the same result. But if I had the add method modify a or modify b, then I would not get the same result twice, and that would not make any sense. I'm doing a plus b, which means that neither value is supposed to be modified. And so if I were to modify one of them, then it wouldn't make any sense, with the operator overloading. And so when you overload operators, you always want to return a new value. You don't want to modify the old values. And I know I'm kind of driving that point home, but it's really important because if you don't do this, then you're going to run into code that is very confusing. Just like that. And that makes a lot of sense. The other thing that I wanted to mention was the not implemented. So not implemented is basically a special sort of type, you can think of it, that Python will look for. And so, for example, if I tried to do, let's say I tried to add a vector and a number, well, Python is going to be pretty smart, and PyCharm is going to be pretty smart, and it's going to tell me that, this is not compatible. I'm expecting a vector here, and this is a number. It's not going to work. And if I run this, then you'll see that it gives me a type error, because what happens is when the add function, when this method gets called automatically by Python sees this plus, it automatically calls this add method, and when it gets not implemented back, then it will raise a type error and say that you can't add a vector and an int. And this is a pretty straightforward, pretty obvious error message. I know exactly what's going wrong here, but basically Python will take care of raising the error for me. I just want to return not implemented when I run into a situation where I cannot do an operation with the specified operands. The other thing that I want to mention, and this might seem a little bit weird, is let's go ahead and try to print 2 times a. And you might say, well, multiplication is commutative, and it really shouldn't make a difference at all. If I can do a times 2, I should be able to do 2 times a. But if I go ahead and run this, you'll see that we get a type error, and it says that I can't multiply an int and a vector. And now this is a little bit confusing, because I thought that I said that I could. I said that if you multiply a vector and an integer or a float, then it would actually work. But this is telling me that it's not. And the reason why this is happening is because when Python runs into a operator overloading scenario, it sees this plus, and it sees that you're working between vectors or something like that, it will basically call the appropriate method on the left-hand operand. So for example, when I do a plus b, it's going to call the add method right here on the left-hand argument, which is a, and here it's going to call the multiplication, the mul method, on the left-hand argument, which is a again. But here it's going to call multiplication on the left-hand argument, which is the number 2. And obviously the int class doesn't know how to multiply by a vector, because we just wrote the vector class ourselves, and int has no idea that it exists. And so does that mean that we can't do this? Well, no, Python thought of that as well. And so for all of these methods that you can override add, mul, div, sub, so on and so forth. There are also versions of these that start with the letter R. So for example, in our case, we want rmul, just like that. The R stands for right, if you couldn't guess. And so to implement this, all we need to do is we need to return self times other, like that. We'll get back to that. We'll explain, I'll explain sort of this in just a second. But basically what's going to happen here is you'll notice that this error went away, and if I run this, it's going to run correctly. So what exactly happened? We saw this mul, this multiplication, and so it's going to call the mul method on the left-hand argument, which is an integer. The integer does not know how to multiply by, a vector, and so the integer class, the int class, would return not implemented. And then when Python sees this, it says, okay, well, if that didn't work, let's try and call the rmul, or right multiplication method, on the right-hand argument, in this case a. Right? And we said that we do know how to multiply a vector and a scalar. And so in this case, what we're doing is if you call it on the right, all we're doing is we're doing self times other, which will end up calling the mul function up here. as you can see. But basically, we're just saying that we support left-hand multiplication, and if you do it from the right hand, we're just going to do the same exact action as the left-hand side. There are certain scenarios where you might want multiplication to work differently when it's on the left versus being on the right, but a lot of the time it doesn't matter, and you can just do something like this. So essentially that fixes our issue right there, and the definition for the vector class is contained entirely within the vector class. We didn't need to add any code to the int class to support vectors. We could just implement this rmul method right here that would sort of take care of that for us. And so that's basically all that there is to operator overloading. There are lots of other operators that you can overload. You can overload all of the math operators, you can overload bit shifting operators, you can overload comparison operators like greater than, less than, equal to, not equal to, so on and so forth. There are lots of different things you can do, but this is just a general idea as to what operator overloading is, how to do it, and why it's useful. So to finish off this video, and I know this is a long video, but to finish it off, I want to look at a couple examples of operator overloading in Python that you might not have even realized was operator overloading because perhaps you didn't know what operator overloading was until you clicked on this video. So let's just look at two very quick examples. Excuse me. And the first example that we'll look at is something like this. You might have run across this code or something that looks like this before, where you have a string and you multiply it by a number. And it does, you could take a second to think about what it does. I think it's pretty clear. It just returns a new string with the original string repeated this number of times. So I said the string hello multiplied by 3, so it's going to give me a new string that has the word hello 3 times in a row. Once again, this is pretty clear. It's not quite as clear as adding two vectors together, but it's pretty clear that when you multiply a string by a number, that it's going to repeat that string that number of times. And it's, a little bit nicer than doing hello.repeat 3 or something like that. You'll also notice that the order doesn't matter, so I can do 3 times hello. I can put the 3 first, and it's going to give me the exact same result. Essentially, we can allow the definition for mul to be contained entirely within the string class. We don't need to write, a mul method in the int class that can handle multiplying by a string. We can have all of the logic be within the string class, and we can use, in this case, the rmul method to, essentially handle when you swap the arguments. One other example, you might have run into this, you probably have run into this if you've worked with older Python code, especially Python 2, and it would be something like this. So hello %s and then something like that. So essentially you have hello and then some string, and then you have sort of a tuple. Now in the later versions of Python, this has been replaced with the format method on the string class, and in Python, I believe 3.6, we got format strings or f strings. But here, you'll see we just have hello and then %s. This is saying we want to put some sort of string here, and then we have sort of this % symbol, and then we have a tuple of all the values. You can do something like %s, %d for a decimal number, aka an integer, and so basically it's going to replace the %s with world and the %d with the number 12, which I just picked randomly. So the output is hello world 12. And so if you've seen this before, you might have thought that it was just sort of a weird like Python idiomatic thing, but in fact what happened is the mod function of the string class was overridden using operator overloading, and it was set so that if you have a string and you mod it with a tuple, that it will actually go ahead and do the string interpolation like you would expect. And so this isn't some sort of weird Python syntax, it's actually operator overloading, albeit used in sort of a weird way. I'd imagine the language designers just wanted a clean way to do this sort of string formatting thing, and they figured there would never be another use for the modulo operator for strings, and so they decided to use it like this. And so perhaps you didn't know that that was actually an example of operator overloading, but after seeing this video, I hope that makes sense to you. And so that's all for this video. I know it was pretty long, but we took a look at operator overloading. We discussed sort of what it means in general and why it can be useful. Then we implemented an example in Python with the vector class. And finally, we looked at a couple of examples within the Python standard library that you might not have known were operator overloading until you watch this video. And so that is all for this video. As always, subscribe if you want to see more. Comment with what you want to learn, what you want me to talk about next. And if you like this video, click the like button. I will see you guys soon with some more coding. Bye for now.